Well, I realized I had pushed pause and didn't push play again. On part C and D on question 14, asked about was the error more serious from the factory owner's perspective and then also from the customer's perspective. So part C, both of those errors would be serious to a factory owner because they're both going to cost the factory owner money. So I think that both would be very serious. The type 2 error generally is probably going to be more serious to the customer. Remember what a type 2 error was, if we look back here, because a type 2 error means that the customer is purchasing a defective item, and that doesn't make customers very happy. So they're going to think that that is a more serious error. However, I do want to point out that in industry, a type 1 error is going to cost the consumer money also, but sometimes you don't think about that. Think about if the factory owner is stopping production and repairing a problem that doesn't exist, and they're losing revenue and it's costing money, then who pays for that? Well, it's the customers, because that cost is going to be absorbed in the purchase price of the items, and it's going to cost the consumer more money to purchase those items. Of course, that doesn't get advertised, but you better believe that's what's happening. So even though the customer would probably claim that a type 2 error would be more serious to them, a type 1 error is going to cost them money as well. One more example I want to look at. A company is willing to renew its advertising contract with a local radio station only if the station can prove that more than 20% of the residents of the city have heard the ad and recognized the company's product. The radio station conducts a random phone survey of 400 people. The first question is, what are the hypotheses? So our null hypotheses would be that the proportion equals 0.2, 20%. So we would have 20% of the residents in the city who have heard the ad and recognize the company's product. All right, so the null hypothesis is saying that 20% do hear the ad and recognize the company's product. Our alternative would be that that proportion is greater than 0.2. Because remember, in your alternative hypotheses is where you really want to put what you hope to prove true. And they are hoping that they can prove that more than 20% of the residents who hear the ad or will hear the ad and recognize the company's product. So part B then asks us, or says, the station plans to conduct this test using a 10% level of significance, but the company wants the significance level lowered to 5%. And the question is why? Well, remember, your significance level is alpha. So now alpha equals 0.05, and that will result in a lower type 1 error. So your alpha level is actually what your type 1 error is. So that would indicate then that the proportion is 20%, the null hypothesis is true, but we think it's higher. So that if you think about what the results of that, so let's write that down. The proportion is 20%, but we think it's higher. So think about what that means. Okay, well, what it means to the company is the company is paying for ineffective advertising. Okay, and they want that to be a lower chance. They don't want to have to pay for ineffective advertising. All right, part C says, what's meant by the power of the test? So remember what the power of the test is. That's a correct decision. So we reject H naught, and that's a correct decision. So what that means is the proportion is more than 20%, and we correctly decide that. Okay, and that's good. That's what we hope happens. Part D, for which level of significance will the power of this test be higher? So, remember we were looking at either a 10%, so we were looking at an alpha level of 10%, or alpha level of 0.05, which is going to give us a higher power of the test. So let's think about that. Well, if we want a higher power, then that means we need to have lower type 2 error, which remember is beta, and that's going to mean we have a higher type 1 error. So if we want to increase the power of the test, we would need to have alpha be the higher level of significance in order to come up with a higher power of the test. And part E, they finally agree to use alpha equals 0.05, but the company proposes that the station call 600 people instead of 400, or the initial 400 proposed. Will that make the risk of a type 2 error higher or lower? Explain. So we're increasing the sample size. So remember, that's kind of the cure-all. Increasing the sample size lowers both type 1 and type 2 error and increases power. That's a good thing. Just a few things to go over, and you don't have to copy these down. Actually, they're towards the end of chapter 21. These are in your textbook. What can go wrong? Don't interpret the p-value as the probability that H naught is true. Remember, the p-value is about the data, not the hypotheses. Okay, the p-value is a conditional probability. Given that H naught is true, what's the probability that we get results as extreme as ours? That's how you interpret a p-value. Don't say my p-value is 0.05, so there's a 5% chance that H naught is true. That is not what a p-value means. Also, don't believe too strongly in arbitrary alpha levels. Okay, so if I tell you alpha equals 0.05, and that means if your p-value is less than 0.05, you reject the null hypotheses. If you get a value of 0.048, that's awfully close to 0.05. You're much better off just reporting your p-value and maybe a confidence interval, and so then someone can make their own decision by looking at that. Don't confuse practical and statistical significance. Just because a test is statistically significant, and again, that means you have a low enough p-value that you reject your null hypotheses, that doesn't mean it's significant in practice. Okay, so sometimes you might be looking at the difference between 15.1% and 15.2%, and you say if your sample size is big enough, you might say there's a significant difference. But that doesn't mean it's practically important, so you have to think about the decision that you're making. Again, the next bullet statement, a sample size can impact that. If your sample is very large, you might find that a very small difference can show something to be statistically significant, but it might not be that important. And remember that you could do everything right and you might still make a wrong decision. So remember that is a possibility.